Good evening, everyone. My name is Robin Reisenfeld, and I'm the Senior Curator at the Madison Museum of Contemporary Art. Before we begin this evening's program, I first wish to thank everyone for tuning in to tonight's Artist Talk with Erika Blumenfeld. There will be time for Q&A after her discussion, so be sure to leave your questions in the comments section below. Tonight's talk is presented in conjunction with the current exhibition, Imaginary Eye, displayed in MoCA's main galleries through Sunday, April 7th. The exhibition examines the similarities between artists, scientists, and mathematicians as they explore unknown worlds and concepts and envision undiscovered realities and phenomena that surround us. Imaginary Eye demonstrates that the separation of the arts and humanities from mathematics and the sciences is contrary to the nature of how each function. This exhibition highlights essential conversations around the vital role of the arts in conjunction with science, technology, engineering, and mathematics, and argues that STEM learning should be reimagined as STEAM learning. Today, there is often a perceived disconnect between the arts and humanities on the one hand and math and science on the other. However, this was not always the case. Throughout history, these fields have been closely intertwined and have influenced each other in many ways. For example, during the 15th and 16th centuries, Leonardo da Vinci, who is primarily remembered as an artist, also worked as a civil engineer and conducted scientific research throughout his career. More recently, during the early 20th century, artists from the German Bauhaus and the Russian constructivists explored architecture, industrial design, and engineering to generate concepts that were ahead of their time and required new materials to be developed. Even in today's popular culture, the Marvel Cinematic Universe incorporates scientific concepts like Afrofuturism, quantum physics, and portals to alternate realities inspired by fractal patterns. Both the artist and the scientist are each in pursuit of finding solutions, often working best when in collaboration with one another. Tonight's speaker, Erika Blumenfeld, is a prime example of a contemporary artist who connects the dots between art, science, nature, and humanity. Her artistic practice is research-based and transdisciplinary, driven by a passion to trace and collect evidence and stories of connectedness across the cosmos and explore human experiences of wonder and meaning that cannot be explained away by a mathematical formula. Blumenfeld has been an artist in residence at laboratories, observatories, and extreme environments, collaborating with scientists and research institutions, including NASA, the Scripps Institution of Oceanography, the McDonald Observatory, and the South African National Antarctic Program. Her work is featured in many permanent collections throughout the United States. A warm welcome to you, Erika, and thank you for joining us this evening.
Well, hi, everyone. Thank you. It's so good to be here with you, and a very warm welcome to warm thank you to you, Robin, and everyone at the Madison Museum of Contemporary Art for this invitation to speak with you tonight. So my presentation is about 45 minutes, and I was asked to focus on my collaborations with science institutions. So I will be taking you through an overview of them. But I always start my artist talks with this quote because I feel it evokes the creative imagination and makes us pause to wonder about the connections across the cosmos. And it is this sense of connection, both poetic and literal, that is at the very foundation of my work as an artist. I have a research-based practice, as Robin was saying, and my work investigates the places where our phenomenological world meets the human experience of wonder and meaning. I've always been interested in pushing the boundaries of my own creative imagination by investigating my artistic inquiries from inside another field. So by adopting a somewhat scientific methodology in my artistic process, I have followed a rather non-traditional studio practice. My creative inquiries have increasingly led me to work alongside scientific and research institutions in order to bring both fields of knowledge into a conversation. And this is what led me to Scripps, which was really my first collaboration with a science institution. So my inquiries are centered at the place where art, science, nature, and culture converge, and I'm most interested in the kinds of questions that lead me to the places where humanity finds meaning in our relationship and our sense of belonging with the natural world. Inquiry is at the root of my practice, and I often think of myself as a collector of questions. Questions like these have evolved over my time working with marine bioluminescence at the Scripps Institution of Oceanography. How can we build empathy for even the smallest creatures among us? And can wonder be a proponent to empathy? In 2000, I had arrived at a point in my work where I began to wonder if it might be possible to work with bioluminescence to create a living installation. I initiated a conversation with marine biologist Dr. Michael Latz after reading an article in which he discussed his thoughts about the links between art and science. Our dialogue culminated in what has now been 2 artist-in-residences at his laboratory at Scripps. And prior to my work with bioluminescence, I had been predominantly working on a series called Light Recordings, for which I build my own camera-like devices and record the presence of natural light onto film. My interest in the physics of light and our perceptual experience of it led me to pursue working with light in other forms. What most inspired me to work with bioluminescence is that it is part of a biological system and is, in a very real sense, alive. Bioluminescence is widespread in the oceans of the world. Light emission is produced as a result of a chemical reaction involving the oxidation of a substrate molecule called luciferin, often invoked by force or movement, such as waves crashing along the shore or a fish swimming in the ocean. In the deep sea, where sunlight is absent, more than 90% of the animals are luminescent. In coastal regions, the primary source of bioluminescence is dinoflagellates, a single-celled microscopic organism that are mostly common members of plankton. Although they are mostly microscopic and seemingly disconnected from our daily experience, phytoplankton produce at least 50% of the world's oxygen, making them a crucial part of each of our lives, as well as essential to Earth's respiratory system. They are literally connected to every breath we take. They are also the base of the aquatic food web. Every marine and oceanside animal, from the largest whale to the smallest fish to shoreline birds, are in some capacity dependent on phytoplankton. And yet changes in marine ecosystems have been documented in most ocean regions around the globe, and the implications are significant. With industries continuing to cause increased toxification of Earth's water system, especially around the coasts, and climate disruption increasing the temperature difference between warm surface waters and the colder, deeper waters, which inhibits the amount of nutrient mixing needed for phytoplankton to thrive, studies clearly show that populations have decreased by as much as 40% since 1950. Losing populations of phytoplankton risks the health of our ecosystem and all life on the planet. The decline has also impacted our ability to have direct encounters with bioluminescence, as coastal bays around the world that were once teeming with bioluminescence have now diminished greatly, and in some cases have vanished altogether. If we see less of them or not at all, will we forget our connection to them? My intent during my residency at Latz Laboratory was to learn how to care for the single-celled organism called Pyrocystis fusiformis, which is one of the larger blue bioluminescent phytoplankton that glows in our ocean. In researching and documenting these organisms and learning how incredibly sensitive to environmental changes they are, I hoped that the work could activate a dialogue about the significance of even the smallest members of our ecosystem. All of these works were created to share bioluminescence at the scale of the organism. In some of the photographic works I showed earlier, the bioluminescence glow and movement were instigated by my own hand, sending a vibration through the seawater that triggered their glow. Each spot and trace of light is a single organism within the population. In other photographic works, the bioluminescent organisms were propelled through an agitation chamber, which creates an entirely chaotic environment that emulates the natural turbulent state of the ocean. In science, this experiment is designed to study the physics of a turbulent flow field. I worked with the equipment to stimulate the glow of the bioluminescence in a controlled environment. By working with low concentrations of organisms and a slow flow rate, I was able to produce single flash events, which depict the luminescent expression of individual organisms. In this video work, the bioluminescent organisms were also flowed through the agitation chamber, but with a high concentration of organisms and a high flow rate. I was interested here in showing the luminous response of a large population of organisms. Over the course of the video, you see 1 million organisms. The piece depicts the bioexpression of bioluminescence in real time and shows the turbulent flow field in motion. To me, the beauty of light captures our imagination, our sense of deep awe. That these organisms give light as part of their natural cycle is wondrous and inspiring. That these organisms are also crucial to every breath we take is both poignant and profound. In 2004, I worked in collaboration with the McDonald Observatory in far west Texas to document a full lunar cycle through an altered telescope and produce a time-based work depicting a full lunar cycle, known as a lunation cycle. A lunation is the mean time between two successive moons, new moons, and the lunation numbering system is calculated from the first new moon that occurred in 1923. Lunation 1011 documents the waxing and waning of moonlight over a 30-day period from new moon to new moon and exists as both a video work and a print edition. I created the piece by exposing 90 pieces of 4x5 film over 30 nights through an altered telescope using self-built lensless camera devices. The varying intensities of light radiating from the moon were recorded directly onto handheld photographic film. The resulting images portray not only the changing quantity of moonlight in its nightly phase, but also records the movement of my own hand, which in free holding each piece of film over the long 2-minute exposures, moved slightly from my own heartbeat and my body's sway in the far west Texas wind on the mountain where the McDonald Observatory sits. This piece captured the relationship between the environment, the technology, and the human implementing it. It is additionally expressed in the completed video piece, where each of the exposures I took over the 30 days were then animated in sequence to the speed of my own heartbeat to produce a moving account of the lunar cycle that is both human and planetary. During my 2-month artist residence at McDonald Observatory in 2004, my artistic direction took a radical turn. Night after night, looking up at the universe through the intensely dark and unpolluted sky, I considered how few people around the world had the opportunity to look up and see the stars, planets, and constellations so clearly and be witness to their profound beauty. These thoughts led me to reflect on the historical versus contemporary relationship between our natural environment and our civilization. While our technologies have stunningly allowed us to see into the microcosm of our bodies and the macrocosm of our universe, we have long been facing a time where our technologies are aiding in certain destabilizing effects to our earth, our water, and our air. Indeed, what is our responsibility to the planet we belong to? And can art be a motivator for change? In the fall of 2008, I was invited by the South African National Antarctic Program to join the expedition of the Interpolar Transnational Art Science Constellation Research Team for 6 weeks starting in January 2009. I would spend 4 weeks on the ice at the Sanai 4 research base station in Queed-Maud Land, Antarctica, which is that red dot on the map, and then nearly 2 weeks on their research vessel back to Cape Town. ITASC consisted of an extraordinary team of artists and scientists, and I was both their artist-in-resident and official team member. Our primary purpose as a team was to experiment with living and working on the ice at a site that was 1 kilometer away from the main Sanai 4 base station in a mobile geodesic tent-like dwelling called Ice Pack, which was run entirely on wind and solar energy. The expedition was designed to be a field phase in the development of this portable, sustainable research station for artists and scientists to do fieldwork in the Antarctic environment. My project, the Polar Project, would need such a structure to implement its final phase. It was of immense importance to be a part of this research project. The ice pack structure masterfully dealt with the challenges of the incredibly powerful winds, but the biggest challenge was dealing with the cold. One stormy night brought the temperatures down well below -20 Fahrenheit. I was there to work on the Polar Project, which is a large-scale project I initiated in 2004. The Polar Project was meant to capture and preserve the changing landscape of these regions at a time when the conversation about the climate crisis was not as widely discussed as it is today. My goal was to create a series of visceral experiences of this remote yet critical landscape so people could build a relationship with them in the hopes of cultivating a sense of ecological empathy to protect these places and ultimately our global ecosystems. During my time in Antarctica, I made a series of what I like to think of as field sketches for the larger project that focused on various phenomena I encountered. The early sea ice volume depicts the Southern Ocean beginning to freeze at the edge of the Antarctic ice shelf. These images mark the moment in Antarctica's seasonal change between the waning austral summer and the quickly approaching autumn. The sea portrayed here froze overnight, beginning its yearly transition back to the thick ice that encompasses the continent in winter. As the temperature of the ocean begins to drop, the surface water, which is less salinated, freezes first. And since the ocean is never still, the newly forming ice knocks about gently on the surface waves, bumping into other bits of forming ice. This persistence of the motion means that the ice plates are always colliding into one another, eroding each other's edges. This results in their round shape called pancake ice. By winter, the sea ice where these images were taken would be around 5 feet thick. The land ice volume depicts various formations of surface ice that occur on the continent of Antarctica, many of which are the result of the incredible force of the wind. Katabatic winds, as they are called, blow out from the large elevated ice sheets toward the sea. The buildup of high-density cold air over the ice sheets combined with high elevation brings enormous gravitational energy, which propels the winds to incredible speeds, sometimes surpassing even hurricane force. The katabatic winds carve deep incurvations at the base of the nunataks, which are the rock mountains, and they blow around them, forming ice walls that are upwards of 50 feet high. Like a moat, the wind scoops surround the majestic rock castles, leaving a frozen lake at the bottom in hues of light blues and ripples like the surface of water. These images were taken inside the wind scoop at the base of the nunatak in the northeastern edge of the Almond Ridge Range near the Sanai 4 base station. They portray the rippling and bubbling of the frozen lake on the floor of the wind scoop, as well as the wind's carving of the surface and the towering ice walls. The ice horizons volume portrays the brilliant color phenomena that occur when sunlight interacts with the vast Antarctic ice fields. These images depict the ice fields on the northern periphery of the Almond Ridge Range, this immense body of ice which extends towards the edge of the horizon in every direction can be thousands of feet thick. With ice particulate blowing constantly in the wind around the snow and ice-covered ground, virtually everything in this landscape is a refracting surface, waiting to scatter and bend light. Antarctica literally holds light within it. As sunlight moves slowly throughout the environment here, it shimmers across and beneath the ice and snow, illuminating the horizon with vibrant color combinations. So my Astromaterials 3D project is an interactive virtual library of NASA's Apollo lunar samples and Antarctic meteorite samples collections, and an information-rich visualization tool for researchers and the general public. This project has evolved as a collaboration between art, science, and technology. Nearly a decade in the making, the Astromaterials 3D project combines high-resolution precision photography, structure from motion photogrammetry, and X-ray computed tomography, producing the very first research-grade interactive 3D models of the exterior and interior of NASA's extraterrestrial samples in a single coordinate system. At its core, Astromaterials 3D intends to provide greater access to NASA's astromaterials collections and the incredible stories these rocks from space reveal through the study of them. I have the great privilege of being both the science principal investigator and the project lead, yet a project of this scale has required an extensive interdisciplinary team at NASA's Johnson Space Center that brings together expertise in the fields of art, professional photography, heritage conservation practices, geoscience, astromaterials curation, photogrammetry, image science, X-ray computed tomography, application engineering, and data curation. Throughout my artistic career, I have been especially curious about the links between nature and culture, inspiring me to study the stories and relationships between our natural heritage and cultural heritage in more depth. In particular, I was interested in both the scientific rigor and the imaginative curiosity that led us to learn that we are made of the same stuff as stars. Remarkably, the knowledge of this cosmochemical lineage arose in great part because of the study of rocks from space, rocks like the ones presented in Astromaterials 3D. Ask any geologist about the processes they study, and they will nearly always end their explanation with the same mind-dazzling statement: but the story is in the rock. I began to think of rocks as scrolls of knowledge that reveal stories of primordial formation. Eventually, a persistent question arose for me. Might it be possible to hold a rock in one's hands that tells the story of the whole cosmos? My question led me to contact NASA in January 2013 to propose the Astromaterials 3D project and was offered the opportunity to do a feasibility study. I began working with an incredible team at the Astromaterials Research and Exploration Science Division at NASA's Johnson Space Center, and a little over a year later, my team and I had produced the first ever 3D model of a moon rock. We were then awarded an official NASA research grant in 2015 to produce the project. NASA's Astromaterial Acquisition and Curation Office, part of the Ares division, houses NASA's collections of extraterrestrial samples. These collections include samples from the moon, asteroids, comets, solar wind, and the planet Mars. Being both scientifically and culturally significant, the samples require a unique conservation approach. Government mandate dictates that the Curation Office develop and maintain protocols for, quote, documentation, preservation, preparation, and distribution of samples for research, education, and public outreach for both current and future collections of astromaterials. My artistic intent with the Astromaterials 3D is to provide a novel and dynamic way to make the NASA's collections more accessible to researchers and the public, so that these incredible rocks formation stories that span our solar system could spark wonder, awe, and stimulate research. My ultimate hope is to give you the opportunity to hold virtually these remarkable rocks in your own hands. So how did we create it? Well, our first step is to take high resolution precision photography, which we call HRPP, NASA's astromaterials are housed in a multi-clean room facility and have strict curation protocols to protect them for research and posterity. Therefore, the rocks must remain inside of nitrogen cabinets at all times during the photographic process. There are also restrictions on what materials the rocks can come into contact with, mainly Teflon, stainless steel, and certain types of aluminum. Therefore, and I get this question all the time, so I always mention it, that we could not put a 3D imaging scanner into the nitrogen cabinet to scan the rocks, as this equipment contains materials that do not meet curation protocols. Instead, I had to develop a method to manually photograph the rocks through the small window of the scientific glass that exists on one side of the cabinet. Using custom imaging setup, I capture images in increments of 7.5 to 15 degrees in rotation and at 15 degrees elevations on both hemispheres of the rock, which totals between 240 and 480 photographs. I use high-resolution professional camera systems that range from 60 to 100 megapixels in order to maximize the surface detail and to achieve a final model texture that is what we like to think of as research grade. The technique provides images that achieve resolutions as fine as 30 to 60 microns, depending on the sample size and the equipment system implemented. This method provides exceptional detail and reliable fidelity of the rock that's meant to meet the quality demands of both today's and future users. We then use structure from motion software to produce our 3D reconstructions of the images using photogrammetric principles. The method uses image processing algorithms and techniques originating in computer vision to resolve 3D models for accurate and detailed visualization of each sample. The software provides a stepwise process that is then manually tailored to each model based on the unique spatial and the specular reflectance properties of each rock, because they vary greatly. Finally, we also image the rocks using X-ray computed tomography. XCT image data provides a complete one-to-one volume data of the rock, and where brightness variation of textural features is related to the density and the composition. These are the images that you see inside the rock when you slice through on the Astromaterials 3D Explorer application, which if you haven't done, I hope you will go to the website and check it out. Finally, the process for registering the coordinate system and combining the SFM model with the XCT data in order to achieve what we like to think of as the fused 3D model of both data sets went through several stages of development before our method was finally achieved. But the Astromaterials 3D Explorer that fuses the models is a custom engineered browser-based software application that on your website browser ingests the exterior and interior image data and digitally fuses them into a single object. So I'm going to go through a little bit of the history of the women computers and then talk through the work that is being exhibited at the museum. And so, but I wanted to start with a little bit of their history. So in the late 1800s, the Harvard College Observatory began to hire a small group of women, previously known as the Harvard Computers, and recently renamed the Women Astronomical Computers. Their task was to study, measure, catalog, and preserve a growing collection of astronomical glass plate negatives. At a time when women struggled for basic rights and freedoms, let alone roles within the sciences, The Harvard computers would come to revolutionize the science of astronomy and astrophysics through their discovery, study, and cataloging of hundreds of thousands of stars. Their work centered around the photographic glass plate negative collection, which is really an astonishing effort by Harvard to photographically document and map the entirety of the night sky. So started in the late 1800s and went on through the late 1900s. Harvard amassed more than 500,000 glass plate negatives in this effort. Because the vast scientific value of the collection of 100 years of photographs of the sky, Harvard began to scan the plates digitally to make the star data accessible to the scientific research community. Called the Digital Access to a Sky Century at Harvard, or DASH. They have been digitizing the plates since 2005 to produce photometry of the entire sky for the study of time domain astronomy and astrophysics. From a research perspective, it is significant and heroic effort that will allow researchers to track and compare variability in the brightness of stars over time. The star data can be used to survey long period variable stars, which have been more difficult to study given their prolonged cycles of dimming and brightening. It can be used to examine variability that could yield to new knowledge about quasars, novae, black holes, and neutron stars, and perhaps even allow for the discovery of novel types of stars or phenomena. So in order to get clean digital scans of the star data, the decision was made to clean the plates prior to scanning. And this included the women astronomical computers' annotated research that they would write on the glassy side of the plate. So this caused a bit of an uproar with the cultural heritage professionals because the women's marks held historic significance, even if the star data held scientific significance. So in 2013, meetings were held at Harvard across the cultural heritage and science fields to arrive at a resolution. They decided that they would photograph the women's notations at high resolution before wiping them so that there was always a digital record of their marks. And they would put aside a certain number of plates of the original markings that were of particular historic value. So by the time I learned about this, this whole thing, there were 425,000 plates that had already been wiped clean and scanned for the DASH project. So for me, the loss of the cultural and historic drawings seemed unimaginable. The contribution made by the women computers have continued to inform contemporary astronomy and astrophysics and will continue to do so. To me, the women's marks show the very instance of their imagination and inquiry into their study of the stars and the glass plate negatives. My immediate response was to find a way to artistically intervene and meet the conversation that was happening between the fields of science and the cultural heritage conservation fields. So I approached Harvard to discuss the possibility of conserving the women's marks through art by developing what I was thinking of as an experimental conservation approach. My initial idea was to do print transfers of their marks directly using conservation materials to lift and consolidate the ink during transfer and then to migrate the women's original marks onto a new substrate. So I have a degree in heritage conservation as well as photography. So I worked with Harvard's conservation departments to test various methods and eventually submitted a formal experimental conservation proposal. At that point, 50 glass plates were put aside for me to work with. And I was scheduled to travel to Harvard to complete the work at the end of March 2020. And unfortunately, as you know, the pandemic happened in March, or started in March, and Harvard was shuttered along with everything else. And unfortunately, eventually my research was canceled. From lockdown, I watched through the DASH website as most of those 50 plates that had been put aside were moved through the process of being photographed, erased, and scanned. When I realized I couldn't move forward with the transfer of the original inked notations, I was eager to find another way to honor the women's marks. When Island Press invited me to be their spring 2021 Arthur and Sheila Prensky visiting artist, I knew I wanted to work with the women's marks in a new way. And over my residency, Island Press and I developed the Tracing Luminaries print edition that is currently on exhibit at the Madison Museum of Contemporary Art. Island Press is a research-based printmaking workshop at the Sam Fox School of Design and Visual Arts at Washington University in St. Louis. And they were really the perfect collaborators because their mission is to invite artists for intensive visiting artist residencies to explore the expansive theoretical and material terrain of the print and the places where the artist's creative activity intersects with the philosophical underpinnings of printmaking. So my first step was to select the plates I wanted to work with, and I did that by going through the DASH archive online. These are some of the actual glass plates and the images of their plate jackets that are in the final print edition. I was interested in plates that told a story across time and in the unique research languages of each woman. Like you'll see that every plate sort of has its own style and way of languaging the notations and the research that they were doing. I also looked through the women's notebooks and would look up plate numbers that seemed to have captured their interest. This is a scan from one of Henrietta Leavitt's notebooks from 1905, where she's measuring and comparing stars on the plate I just showed you before, B20645. I spent several months manually looking through thousands of glass plates, and at that time there was no search feature for the women's markings. You could only search by stellar data. So although my understanding is that with the new website that just launched, you are able to search for the women's research directly. This is a wonderful example of the history of the marked plates. So the women themselves would on occasion erase their own marks to correct research or to do additional or new research. So this plate had ghost marks from previous wiping, which we discovered while working with the digital reproduction photograph of the marks. So for me, understanding that they would work and rework their research directly on the plates, which included erasing and remarking their scientific findings, helped me to create rules by which I would honor their decisions. So if the women had erased the marks themselves, but I could still see the ghost of it in the digital file, I did not carry those ghosted marks forward to the final print. I only included the marks that they wanted seen. So I'll talk you a little bit through the process of how the prints are made. And really to start, my primary goal for this work was to return the women's marks to the stars through the materials. So I knew from the beginning I wanted to work with gold. Gold is created through the collision of neutron stars in kilonova events, which have enough energy to create the heavier elements. So for me, gold was a perfect star material. I tried working with platinum palladium photographic processes initially, as these are also heavier elements, also formed in such kilonova events, but I really wasn't happy with the results. So I ended up turning to cyanotype. So while I was working with the digital reproductions of the glass plate negatives, I digitally inverted them to see their positive, which is this. And you can see the difference from the negative image to the positive image. So as you can see, when I flip through, the negatives themselves are black and white. They have no color. But because the glass plates were over 100 years old, they had some yellowing. And that yellow became blue when I digitally inverted them. And essentially, the yellowing is capturing, which were captured by the dash reproduction photos on the plate. They were capturing the aging characteristics of the photographic emulsion itself. But the inversion of the yellow hue made the starry night sky behind the notations this midnight blue, which reminded me of the deep cyanotype blues. I also loved that the cyanotype process was discovered by a well-known astronomer, John Herschel, who used it to copy his astronomical notes. Herschel also is credited for the term photography, where photography and graphy mean to write with light. So working with the students at and the master printer, we worked with Okawara paper, and the first coat of the cyanotype chemistry was rolled onto the paper, and then the cyanotype was exposed to the light of our star, the sun, for 20 minutes. And then it was coated again and exposed for a second time for 20 minutes, so that each cyanotype held 40 minutes of starlight in its exposure. After the exposure, the wash bath develops the cyanotype and essentially stabilizes it. And this is when you see the blues for the very first time. I was interested in the darker hues, but each cyanotype is unique with a lot of variation and texture. To create the intaglio plate, we used cast acrylic and laser etched the women's notations into the surface. To do this, we worked with the photographic reproduction image that Dash had taken of the notations, but first we had to digitally remove the notations from the stars. And really it was removing the stars from the notations, using software to carefully separate the women's writing while keeping their detail intact. Then the plate is inked with transparent ink so that there is invisibility in the ink layer. And here, Tom Reed, who is the Island Press master printer, is wiping the excess ink off the plate. Then the plate is ready for the press. So first the plate is registered in place, which is what I'm doing here. Then the cyanotype and the backing paper are laid down. The blanket is positioned on top and then hand cranked through the press. When it comes out of the press, it looks like this. The cyanotype is adhered and set to the backing paper. The faint lines of the women's marks are barely visible because the ink is transparent. But what you see is the raised embossment of the marks catching the light. So the gilding process is a special part of the process for me. This is where the hand of the gilder must retrace the hand of the women computers. So the gilding process for me is really the alchemical moment of the project, where their marks are returned to the stars through the action of care. Once the gold is laid down, the excess is gently brushed away. This leaves a very faint glitter of gold particles that get caught in the paper. I like to think of these as spontaneous star fields. And as this process is done by hand, every print has its own star field. In my lifetime, science has confirmed the remarkable epiphany that we are made of star stuff, a topic that is deeply embedded in all of my work over the last 10 years. And this idea that we are made of stars is attributed most often to Carl Sagan, but the concept and the words themselves had been put forth by a handful of scientists dating back to the early 20th century, including Harvard College Observatory director Harlow Shapley. In 1929, Shapley is quoted in a New York Times interview as saying, "We are made of the same stuff as the stars. So when we study astronomy, we are in a way only investigating our remote ancestry and our place in the universe of star stuff. Our very bodies consist of the same chemical elements found in the most distant nebula, and our activities are guided by the same universal rules." So in closing, one of the responsibilities that I feel artistic knowledge has in collaboration with scientific knowledge is to nurture and defend the important role that the felt experience and meaning making has in the search for understanding the mechanisms of our world, that our subjective personal experience is important in our truth seeking. Felt experience of meaning play a critical role in our ability to maintain our sense of humanity, and it is becoming ever more discussed that the role of empathetic exchange across disciplines may very well define the future of problem solving and our ability to balance the many social and environmental challenges we face as a species. Some of the questions I've been asking myself over the last 20 years that I will leave you with today are these. How far-reaching is our capacity to connect ourselves to our world? Could the practice of engaging in states of wonder every day help us remember and maintain our eons-long connection and love for the world that evolved us? Could wonder lead to an empathetic response to our current environmental and social predicaments, reminding us that we are connected to the entire cosmos? The story of connection and belonging is all around us, in the stars in the night sky, in the rocks of this planet and others, in the organisms and non-human beings that we share this world with, and in the star-made elements that comprise our hearts and minds. Thank you, and I'd love to take your questions if you have them.
Thank you, Erica. That was really tremendous. It was just great hearing you walk us through your projects, which, as you were talking, just, to me, made me realize how deeply researched they were, and your dedication to this sort of body of work, this field of research that you are pursuing. There are a few questions, and one of my questions is very similar to one of the ones that has appeared up on the screen, which is basically, was there a kind of point in which you decided to pursue this kind of blend of artistic practice and scientific research? What really kind of, I guess maybe was there an experience that influenced you or to go in this direction, or was there, a person, that who you were enamored with, or inspired by?
Yeah, that's a great question. I had the good fortune of growing up in a household with art and science almost equally, and so I feel like I was primed throughout my childhood, and even looking at the things that I would do as a child, like I was always doing art and dance and music, and I was also in the rocket club and in the computer club, and interested in chemistry and that sort of thing. And so I think that when I finally found my voice in the photographic medium in high school, it isn't a surprise to me today, looking at the vast correlation between art and science that's inherent in the medium of photography.
Right.
you know, lens physics and chemistry and all these things are embedded. So I feel like there was this long growth of an interest in art and science across my early life. And then, I moved into photography, and really I feel like it was probably in 1998 when I discovered the light recording, and started making this whole series of works where I was building my own cameras and working directly with light phenomena. And that's a whole story. That's a whole talk, actually. But briefly, I feel like that was really the beginning of me bringing my interest in light and physics, in understanding the phenomena of our world and how these things connected, and how I wanted to start to communicate them as experiences, to bring people into a new way of looking at the world that we live within.
Yeah, I think one of the through lines in a through line in the different projects that you presented was your interest in light. And can you expand a little bit about how you are thinking about continuing this exploration as you move forward in your artistic practice?
My interest in science or light, or
well, it seems like light is the sort of kind of the element that is kind of carries through a lot of these projects, if not all of them. And so and you've kind of you're exploring it in different ways through your photographic process. That last project you described that is now on view in the exhibition it's exquisite because it's so tactile, I think, and visceral. And yet you started with these kind of, images that are very almost ghost-like, I would imagine, as you were, working with them. So, and you're taking that, and also you're going beyond just the photographic process by translating these works into prints as well. So I'm just curious how you think about continuing your exploration of light.
Oh, that's a great question. I feel like my obsession with light is really a lifelong relationship. And, I guess I would start by saying that, my father tells me that light was my first word. And so there is this strong connection that I think I've had since I was very, very tiny, that has carried through all of my work and has carried through my interests. And, I feel like light is so mysterious, and it has been the subject of so many artists' work. And there's infinite number of ways to imagine working with light ongoing. But I have very specific ideas about what I want to do next in my capacity for working with light. And really, I feel like this work, if I'm able to achieve this next body of work, will be a new experience for me in terms of my relationship with light. So I've been very slowly and very behind the scenes, although I have publicly announced this project before, been working on a project in my light recordings body of work where, in that work, I was recording the light of the sun and I was recording the light of the moon. And it occurred to me about a little over 20 years ago, could I record the light of Earth? And so there is this, there has been this long interest in following this pathway. And so over the last few years, I have actually been pursuing this effort. And so the light of Earth essentially is the reflected sun sunlight that has bounced off of everything on our planet, has interacted with everything within our biosphere, including us, our human world, the natural world, and then back, and the portion that reflects back into space is the light of Earth. And this is actually called albedo. It's something that scientists study actually for climate change and the energy budget. But what I'm interested in is the fact that because that light has interacted with everything in our biosphere, it carries the signature of us, right? It carries the signature of everything. So the idea is to, and the only way to record the light of Earth is from space. So the idea is to send a custom camera that I'm building to the International Space Station to record the light of Earth from space, to create a holistic portrait of Earth as light.
So what a fabulous project. Very ambitious. I can't wait to see it.
Thank you. I'm well on my way.
That is great.
I hope to have announcements this year, so we will see. I will keep you posted.
Keep me posted, please. Yes. So one more question, and I think we're probably running out of time here. Do you have any recommendations on how others could expand their sense of wonder to build empathy as you have in your work and as you mentioned in your introduction?
Yes, I would say follow your curiosities. I mean, let yourself be curious about the world and that you live in, your immediate environment, and let the world communicate to you, and then follow those curiosities into wherever they lead you. I think that the real commitment to expand our sense of wonder is a commitment to love the Earth, and to love the cosmos, like everything. The Earth is in space, so everything beyond Earth is still part of the Earth environment, right? So anything that anything within our natural world, within our universe, within our cosmic world is I think fair game for the sense of wonder. And building empathy is really just letting yourself feel the experience, right? And I think that we're so overwhelmed in our world today with all of the information that we have, but when we let ourselves really sit in a place of our environment and feel into what the environment has to share with us, we learn so much about how we're connected to it. And I think that's really the spark for me is curiosity. Yeah. and questions.
Yeah, that's great. That is really a great lesson. I think a great point or juncture for which to close the program. I want to thank you again so much. And I look forward to seeing more of your work. And I want to remind everyone that Imaginary Eye will be on display at the museum until Sunday, and you can see Erika's work, and it's really worth the trip. Admission to the museum is always free. And just a couple of words about our sponsors. Major sponsorship for Imaginary Eye is provided by the Robert Lehman Foundation. Generous support for the exhibition programming is provided by the Wisconsin Arts Board with funds from the state of Wisconsin and the National Endowment for the Arts. Additional support is provided by Dane Arts with additional funds from the Endress Manufacturing Company Foundation and the Aju Foundation, the charitable arm of the Capital Times, as well as the W. Jerome Fauci Foundation and the Pleasant T. Rowland Foundation. And as we thank the sponsors who helped bring this exhibition and related programming, such as the Swinton Night, to the museum, MoCA would also like to thank the Ho-Chunk people on whose ancestral land Madison was built and acknowledge the 11 other First Nations of Wisconsin. And if you wish to learn more about our upcoming talks and presentations at MoCA, you can visit our website at moca.org and by following us on social media at MoCA Madison. Thank you so much, Erika, and everyone else for joining in this evening.
Thank you so much.
Thank you.